Good morning everyone. My name is Neelam Sharma and in this presentation I am going to explain you MapReduce architecture and Hadoop programming topic of big data. So these are the contents of the presentation. Introduction to Hadoop. Hadoop is an open source framework which is used to store and process big data. Big data means data that is too large for a single computer to handle. Hadoop solves this problem by connecting many inexpensive computers together to form a cluster. This means we don't need costly, high-end servers. Even regular machine can be used to process large amount of data. The main feature of Hadoop design are scalability, which means it can grow easily, cost effectiveness, it's affordable, and fault tolerant. It keeps working even if some machine fail. Hadoop is based on a programming model named MapReduce. Hadoop architecture. Hadoop architecture has two main components: HDFS, which means Hadoop Distributed File System, which breaks large files into small blocks and store them across different machines in a cluster. Even if one machine fails, the data stays safe because Hadoop keeps multiple copies of it. Second one is MapReduce. This is the processing engine of Hadoop. It divides big tasks into smaller parts, processes them in parallel, and then combines the result to produce the final output. Hadoop also has two additional models, which is Hadoop Common, which provide libraries and utilities needed by other components, and Yarn, which manages jobs and system resources in the cluster. Now talking about the MapReduce architecture. In the MapReduce architecture, it divides the job into smaller tasks, executes them in parallel across a cluster, and merges the result. It designed ensure parallelism, data locality, fault tolerance, and scalability, making it ideal for applications like log analysis, indexing, machine learning, and recommendation system. Core component of MapReduce architecture. The MapReduce follows a master-slave model where the job tracker, which is the master, coordinate tasks, and task tracker, slave, execute them on cluster node. Below are the two main components. One is the client. It is the entry point in MapReduce. It submits the job for execution by packaging the mapper and reducer logic into a jar file and specifying the input and output path. The job. A job represents the complete processing request from the client. Internally, it is divided into job parts, tasks. Each job part is assigned to either the map or reduce phase. Job parts. Every job is divided into smaller units called job parts, map job parts, and reduce job parts. Now talking about the phases of MapReduce architecture. There are three main phases. One is map phase, second is shuffle and sort phase, and third one is reduce phase. Talking about the map phase. In this phase, the input data is divided into small parts called splits. Split is given to a map task which processes the data and converts it into key value pairs. For example, if the input is hello Hadoop, the output will be hello, 1 and Hadoop, 1. The second phase is the shuffle and sort phase. After the map phase, the outputs are grouped and sorted based on their keys. For example, if we have many Hadoop, 1 pair, they are grouped together as Hadoop 1, 1, 1. Reduce phase, the group data is combined or summarized. For example, Hadoop 1,1,1 becomes Hadoop 3. Finally, the result is written back to HDFS, Hadoop Distributed File System. Now coming to the execution flow of MapReduce architecture. First, the client submits a job. This job includes the input path, output path, and the mapper and reducer logic, the code that will process the data. Next, the job tracker, which divides the job into smaller tasks and assign them to different task trackers, workers in the cluster. The map tasks then produce the data that is stored locally on their machine. After that, the shuffle and sort step organizes the result from the map phase. Finally, the reduce tasks combine the data and produce the final output, which is saved back into the HDFS. The biggest advantage of this process is data locality. The data is processed on the same machine where it is stored, which reduces network traffic and makes the system faster. So, Hadoop MapReduce also uses some smart optimization to work faster and more efficiently. First is speculative execution, which means that if one task is running very slowly, Hadoop starts a duplicate copy of that task on another machine. Whichever finishes first is accepted, which helps save time. Second is load balancing, which makes sure that all the machines in the cluster are used evenly and efficiently, so no machine stays idle. Third one is fault tolerance, which means that if a task or machine fails, Hadoop automatically runs that task again on another machine that has a copy of the data. Fourth one is pipeline execution, which allows multiple tasks to run at the same time, which increases speed and performance. Now let us talk about the advantages of MapReduce architecture. It includes the parallelism. Many tasks run at the same time on hundreds or even thousands of computers. Efficiency. Data is processed on the same machine where it is stored, which reduces data transfer and saves time. Scalability. When data grows, you can easily add more machine to handle it. Simplicity. Developers only need to write simple map and reduce function. Hadoop takes care of everything else. Fault tolerance. The system keeps running even if some machine fail, making it very reliable. So in summary, Hadoop is a distributed system that stores and processes big data efficiently. MapReduce is the engine that performs this processing in map, shuffle and sort and reduce phases to produce the final output. With its features like parallelism, scalability, and fault tolerance, Hadoop MapReduce has become a trusted and powerful solution for handling big data.